4.5, number 227. We have the function f of x equals x to the 11th minus 6x to the 10th. And we want to find where it's increasing or decreasing, its local maximum or minimums, and anywhere it has inflection points, and the concavity of this function. So we will need to do the first derivative test and the test for concavity. So f prime for the first derivative test will be 11x to the 10th minus 60x to the 9th. We want to know whether this is equal to 0 or undefined. But since it's a polynomial, we know it will not be undefined anywhere, i.e. it is always defined. So therefore, we're really just looking where where the derivative is equal to 0. So we now factor it as much as possible. 11 and 60 have nothing in common, so we take out x to the 9th. We're left with 11x minus 60. This is all equal to 0. This outer factor of x to the 9th implies that x could be 0. And the other factor, 11x minus 60, implies that x might be 60/11ths. All right, so there's our two critical values for f. So let's go ahead and do the first derivative test and complete that part of the problem before we move on to the concavity and inflection points. All right, so we're going to put 0 on here and then 60/11ths wherever it falls out. Over here, 60/11ths. Again, the scale does not really matter so much. All right, so we have three intervals, 1, 2, 3. We need to take some test cases perhaps. And really, this is the type of problem I've talked about before. You only need one test case to determine the entirety of the sign chart. And that is because we know that once we get one of the signs in here, it has to alternate across here because this factor is to an odd power and this factor is to an odd power. All right? So that means all the roots here are odd multiplicities. So let's just take the simplest case possible. We'll just pretend that x is a giant, colossal positive number over here, okay? So imagine x is a colossal positive number. So in here, 11 times that will certainly outweigh the 60 subtraction, and then in here, they'll be positive because it's just a power of a positive. So therefore, if I pick an extremely large x value, this factor will be positive, this factor will be positive. Therefore, the product is positive, therefore the first derivative will be positive, and that was happening way out here past this 60/11ths value, right? A very large positive number. So now we know it has to be alternating, so we should have a structure like that. That is the sign of the first derivative, so therefore the original function f is increasing, it is decreasing, and then increasing again on these three intervals. Now we know the answers to part A and B. So part A, we have increasing on two intervals, negative infinity to 0 and 60/11ths. I can't see that right now. 60/11ths to infinity. And is decreasing on 0 to 60/11ths. All right, simultaneously knowing that, we must also end up knowing the relative extreme locations. So part B, we now know there's a relative minimum at, it was going down here and then going up, so it's 60/11ths. 60/11ths, comma, something, we'll determine momentarily, and we have a relative max at the other location, right? We know it was going up here and then going down conceptually, so therefore we see this relative max at 0, comma, something. Okay, the 0 value is easy to figure out. 0 back into the original up here. Certainly f of 0 is 0 because it's just powers of x here. So we get 0 back down here for the corresponding y value for the maximum. And now the 60/11ths will be more difficult to compute because of these powers of x. So let's just write over here very quickly what we have. F of 60/11ths will be 60/11ths to the 11th power minus 6 times 60 elevenths to the 10th power. So let's take out the 60 elevenths to the 10th power. We're not going to write this out as a final value, but just to at least make it look better. Simplify a little bit here if we don't calculate the value of the whole thing. So 60 elevenths to the 10th power, and we'd have left inside here a 60 elevenths from this factor, from this term, 60 elevenths, and then minus just 6 itself, okay? So what would that give us here? So 60 elevenths minus 6, this 6 would really be 66 over 11. We'd have negative 6 elevenths, okay? So this should be the same as 60 elevenths to the 10th times negative 6 elevenths. Okay? So rewriting that, we could have a few ways of writing it, but let's just write it like this. Negative 6 times 60 to the 10th over 11 to the 11th. Okay, we'll just leave it like that. There's no reason to compute the final value. It's too cumbersome, and it's more concise written like this, to be honest. So if I can fit that in here, negative 6 times 60 to the 10th over 11 to the 11th. All right, there's our answer for the relative extreme locations.